homogeneous function of degree n by Euler's theorem x into dou z by dou x plus y into dou z by dou y equal to nz, where u equal to f into x comma y. That means the function in x comma y equal to x into du by dz plus y into du by dz. Now we are going to solve a problem regarding to Euler's theorem. Now this is the problem. What is the problem? Verify Euler's theorem for z equal to ax square plus 2hxy plus by square. So where z is a function, let it be written as let z equal to px comma y. The function in f x comma y equal to ax square plus 2h xy plus by square. Now it's time to take in one variable is k, that means kx comma ky. Now here we replace x in the place of we replace kx in the place of x. Now what it becomes? It becomes a into kx whole square plus 2h into kx into ky and also plus b into ky whole square. Now the equation becomes in the form of a into kx whole square plus 2h into kx and ky plus b into k into y whole square. Now it's time to expand this form. A into k square x square plus 2h into k square xy and also here we have b into k square into y square. Now it becomes in this whole expression k square will be the common and let it be written as outside of the expression. What it becomes? K square into a square x square ax square plus 2h xy by square. Now this is in the what is this? Previously already we are discussed about this. What is the function of this? In the place of ax square plus 2hxy plus by square, let it be written as the function f of x comma y. It clearly says that this is a homogeneous of degree 2. That means k square into f of x comma y is a homogeneous of degree n equal to 2. Now this is the highest degree in this expression. Now what is the degree of this is the value of n equal to 2. Though clearly it says that verify Euler's theorem for z equal to x square plus 2hxy plus by square. Initially we are going to take the function f of x comma y equal to ax square plus 2hxy plus by square. In the place of, and next step, in the place of x we have to replace the kx in x and also y in the place of ky. Now the expression becomes a into kx whole square plus 2h kx into ky plus b of ky whole square. Now the expansion of ax square plus bx 2hxy plus by square becomes as the function. Previously we let f equal to x comma y. It becomes the function. Clearly it says that k square into f of xy is a homogeneous of degree n equal to 2. Now it's time to solve these one by one. What is the formula here? x into dou z by dou x plus y into dou z by dou y equal to nz. Now written as it is x into dou z by dou x plus y into dou z by dou y equal to nz. Now let us take LHS. What is LHS? We have dou z by dou x plus y into dou z by dou y. This is LHS. Now it's time to solve x into dou z by dou x plus y into dou z by dou y. What is the meaning of dou z by dou x here? Dou z by dou x means the partial differentiations with respect to the x, and also this time this is also the partial differentiation with respect to the y. Now let us solve separately. Dou z by dou x equal to, what is the value of z? In the starting we are going to written as ax square plus 2hxy plus by square. Now we already familiar in differentiation. What is the formula of x power n here? The derivative of x power n here, what is this? Derivative, that means d by dx of x power n equal to n into x to the power of n minus 1. This is the formula for derivative of x power n with respect to the x. Now it's time to also we are going to find derivative of x equal to dx by dt becomes 1. So these are the two important formulas we have to remember from differentiation. Now it's time to use a partial differentiation here. What we get? Dou by dou x of ax square plus dou by dou x of 2hxy plus dou by dou x of by square. Now a becomes constant. Now it's time to written as in front of the expression. What we get? Dou by dou x of x square, that means d by dx of x, d by df of x power n, that means differentiation of x power n with respect to x equal to n into x power n minus 1. In the place of n we have 2 here, that means 2 into x power n minus 1, that means 2 minus 1 plus dou by dou x of, so these three are the constants. Why? We are going to solve in with respect to the x, that means x into x 2hy plus, so here we are going to differentiate with respect to s. Here we have y is the constant term here, so this will become 0. Now becomes 0, and it's time to write as 2a x plus dou by dou x of x, that means d by dx of x. What we get here? 1 into 2hy, so it's not important to written as 0. Now what is the value of we get here? Dou z by dou x equal to 2ax plus 2hy. By using partial differentiation we get dou z by dou x value is 2ax plus 2hy. Now it's time to finding what dou z by dou y. At this time we are going to derivate this term in with respect to the y. Now let it be written as, now we are going to differentiate with respect to the y. Now ax square, that means we have x term here, it becomes 0. what is the mean? That means it's time to substitute the formula and do into ax square plus dou by dou y of 2h xy plus dou by dou y of by square. So what we do here, dou by dou y equal to a into x square plus dou by dou y equal to 2hxy plus dou y into by square. Now it's time to apply partial differentiation with respect to the y. So here we don't have any y term, so this will become 0 plus. So in this time these 2hx are the constants here. 2hx, what is the value of dou y by dou y? Becomes 1 plus previous already with respect to x, what we get? N into x power n minus 1. Now it's time to differentiate with respect to the y. Now y term, what is the y, what is the formula for dou by dou y of y square equal to n into y power n minus 1. So as it is in the place of n, initially b is the constant here. Now let it be written as in front of the expression. What we get? That means 2 into y power 2 minus 1. That means in the place of n we have 2 here. So if we get any doubts, it's time to written as dou by dou f of y square equal to 2 into y power n minus 1. So are you get the clarity here? Now it's time to written as so no need to write a 0 value, 2h x plus 2b y1. What is the value of these? Dou z by dou y. So this is the value of dou z by dou y and this is the value of dou z by dou x. Now previous already, what is the formula we get here? Dou z by x into dou z by dou x plus y into dou z by dou y equal to nz. So this is secondary. Now it's time to take as LHS. It's time to substitute the values. That means dou z by dou x and dou z by dou y values in equation. Let it set to be equation number 1. It's time to substitute dou z by dou x values and also dou z by dou y values in equation 1. First of all, what is the value of dou z by dou x? Let it be written as x into dou z by dou x values we get 2ax plus 2hy and also we get the point of y into dou z by dou y values. What we get? 2h x plus 2by. Okay. Now it's time to multiplication with x. What we get here? 2ax square plus 2h xy plus its multiplication these two terms with respect to the y, we get 2h xy plus 2b y square. Okay, or you get the point? Now what we get here? 2a x square plus 2hxy plus 2hxy. That means 2 plus 2 becomes 4h xy plus 2b y square. Okay, are you get my point? Now it's time to here 2 we have. What how to write this for? 2ax square plus 2 into 2hxy plus 2b y square. The number 2 is common in all expression. The 2 will be common and it is written as outside of the expression. We get ax square plus the 2 will common and written as outside of the expression 2hxy plus this also will be common. What is the remaining equation? By square. So once observe here 2 into what is the value of ax square plus 2hxy plus by square? In the first starting sum we already discussed about this term. What is the value of ax square plus 2hxy plus by square? Z. Okay, it's time to replace ax square plus 2hxy plus by square, the value z. So or get we take here LHS as, now it's time to see this, and this equation we solve x into dou z by dou x plus y into dou z by dou y equal to nz. Here we take LHS and it becomes right side equation what we have nz. So this is the required homogeneous of degree. Now what we had from equation 1, what we get? X into dou z by dou x plus y into dou z by dou y equal to nz. So the Euler's theorem is verified successfully. Any doubts regarding to this, don't forget to comment in our comment section. Okay, thanks for watching. That's all for today. For more videos, don't forget to like, share, subscribe our channel. Thanks for watching.